All right, so I figure I'm going to start with a demo. And what you see here is a fully patched hypervisor called Hyper-V. I guess some of you are using that maybe in your production. If you're using Azure, then you're using that because that's how you run a virtual machine in Azure and so on. And we have one virtual machine here. It's called Server 1. And in this prompt here, we have the hypervisor. So you can run get VM, for example, and you can see all your virtual machines. And if you run get VM, and then you get like the ID and the name, not select. There we go. Okay, so that's the VM ID of this virtual machine, right? So in Hyper-V, there is this concept of PowerShell Direct. And PowerShell Direct is like the modern way to manage your virtual machines. So you can, from the hypervisor host, run PowerShell commands inside the virtual machine. And it's pretty cool because it doesn't require networking, and there's a lot of backup solutions and so on that rely on it. So if we do invoke command and we say VMID, and we specify the VMID we just copied, and then we say script block, and we say host name could be the command that we want to run. And then we specify the credentials, because this is going to run in user space inside the virtual machine, so we need credentials to do that. We run the command, and we see that we get server 1 back. All right, so this is good and all, and this is something that is a way to manage your virtual machines. So imagine now that this virtual machine got compromised. A threat actor runs this script called exploit PS1, which starts a listener. And the admin on the hypervisor host doesn't know that it happened, of course. So as part of their daily job, they just run this exact same command that we just run. We expect the output server 1, right? We run it. It takes some time to complete. And after a while, we see that something bad happened, and we got this weird exception. And after a while here, we see that we got a shell. So now we're actually executing commands from within the virtual machine on the hypervisor host. And we can see that we are now on Hyper-V01. And of course, we can pop the mandatory calculator, and we get our calc on the hypervisor host. All right, so to understand how that worked, we need to start from the beginning of all of this. And we're going to start with this bookcase called Billy. In code, that is a class, bookcase, and the property name is Billy, and the property price is something, and so on. And you have this object-oriented concepts in programming, right? You can create a new object of that class, and then you can execute the methods, and it's going to take the members of the current state of the object and so on. Here we have a serialized Billy. He's much easier to transport than the object that you have in the store. And if you talk about this in code, then you have just a serialize function, and then you can write it to file, and you can do whatever with that data that you're going to get out. It can be stored in a database, it can be sent over the network, and that kind of thing, right? In this case, it's transported with some kind of truck. On the other side, when it's received, we have the deserialization of Billy. And code-wise, you read in the bytes or whatever text there is, you deserialize it, and you get your object back, and there you have Billy. So what we what we explained now is the very basic concept of serialization. It's something that a lot of programs is using, and it's a very fundamental concept of software design. So what could possibly go wrong here? So what if this delivery guy is evil and changes out the delivery and delivers this instead? If there's no input validation or something, then we can end up with something like this. But of course, that wouldn't work because this person doesn't have a cow at home. So this would actually throw an exception because you can't just inject classes when you exploit a deserialization. You need to abuse the classes that are already there. So we call those things gadgets. And in this example, maybe they have a dog, maybe that will work, and that has some features that can eventually do whatever we want to do. In a programming sense, we would start looking for specific classes, like Oren Sai talked about it a bit yesterday, right? He was able to read in user share and then find useful stuff where we're able to read stuff, right? It's kind of the same thing here, but we want to find things that we can instantiate, and hopefully it's going to trigger some kind of function in the backend, and we're going to be able to get an impact. So basically, the impact is going to depend on what specific gadgets the victim have on their system. So the impact is going to vary. Okay. I started doing this research back in 2018. And I also have a job, so I haven't been doing this full time since then. This is more of a hobby kind of thing. But at that time, there was two really interesting papers on this, and it was deserialization in Java, and then deserialization in .NET. And after that, there's deserialization in most languages, but not in PowerShell. So that's what we're going to look at today. How can you exploit a deserialization vulnerability in PowerShell? And what kind of impact could that have? And as you saw in the demo, the impact can be quite severe in some cases. So if we summarize what we learned so far, developers are using deserialization all the time because they need to read and restore and so on objects. And the vulnerability itself, that's when you deserialize untrusted data. The impact of the vulnerability is going to depend on whatever gadgets you have. All right, so what is CLI XML? CLI XML is a very common serialization format in PowerShell. Imagine that you have this string, you serialize it, it's going to be stored in this XML format. It has support for these primitive types, for example. So if you have a Boolean, it's going to be this B tag, and you're going to have integer tags and that kind of thing. It also has support for complex objects. So in this case here, you see the very basic template for it, but it can be lists, and it can be stacks, and there's a bunch of different data structures that it supports. If we take this class system drawing point as an example, we see that it inherits from value type, it inherits from object, and that's within that TN section that you see there. You also see the definition of the properties. It has this one property called isEmpty, and it's a Boolean, and it's set to false. So when this is read back, then that's going to be the value of the object that is serialized, right? So one very important concept here is that we have something called property bags. So if you take, for example, a Boolean, you serialize it to this B false B, and you deserialize it again, then you're going to get an actual Boolean. It makes sense, right? What if we serialize this system drawing point, and then we deserialize it? Then we're not going to get the actual system drawing point class back. We're going to get another class, which is called deserialized system drawing point, and that is something called a property bag. You can think of it as a dict in Python or something like that. So it's pretty much just this worthless dictionary which just has the properties, but we don't really have any of the functions in the original class, because it's not an object of the original class. It's something else. And of course, this is going to be important for us, right? Because like we talked about before, we want to find that class that we can abuse, right? And if we cannot use the original functions and so on in that class, then yeah, it's no good for us as threat actors. So when you've done that serialization, the direct way to do it in PowerShell is just use this import CLI XML. Maybe you used it once or twice. You can also use the PS serializer class directly. That's actually what's going to happen if you run import CLIXML under the hood. So it's exactly the same thing, pretty much. And if we follow the code, because PowerShell is actually open source nowadays, and Windows PowerShell isn't, but PowerShell Core is. But I guess that they want to keep this serialization compatible between the two. So I guess we can guess that they are fairly similar when it comes to this. So basically, if we follow the flow, we see that it ends up in this read object. And if we take, like, how does it deserialize the primitive types, for example, we see that it goes all the way into this internal serializer, which is called the serialize-on. And in the case when it's a known primitive type, it's going to use a table and find the correct function for doing the deserialization. So in the case of a Boolean, then it's going to call this deserialized Boolean, and it's going to use like the XML convert, blah, 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 to convert it to a Boolean. So that's the like known primitive types. If we just start like looking at the known primitive types, is there anything bad we can do? And I realized pretty quickly that script block is a known primitive type. That could be an interesting class, right? But unfortunately, it's like by design deserialized to a string. And there's a lot of people asking on GitHub, can you please rehydrate my script blocks? And they say, nope, we've done enough pen tests to know that that's not a good idea. So at least they've been thinking about this, right? So that's good. And if we jump ahead a bit, so keep in mind, like I said, I started this around like 2018. And I work as a forensic investigator at TrueSec, and we did a lot of investigations when this thing came around. It was quite a few companies that suffered from proxy shell, you might remember. And one of the exploits, it was several exploits, right, and variants of that original exploit, which, by the way, Orange Desai, talked to him, he's awesome. He was the one who initially discovered it. He's here. But the other variant, proxy not shell, it used Orange size SSRF as the first step, but then it changed this other part to get execution in the PowerShell backend. And when I investigated this, I realized that, oh, this is CLI XML in the actual exploit. So what is this? So I started digging into the actual exploit, and it seems that there is this interesting concept of user-defined types in PowerShell deserialization. And Exchange defines one of those. So it has like its custom serialization type converter. And if you look in the source code there, it's basically just wrapping binary formatter. And binary formatter is something that in JSON, the 13th JSON blah, blah, blah attacks, the paper, they figured that that is exploitable. So it's a known vulnerable function to deserialization. And the way that they abused that was that they specified the target type for the deserialization, and they specified the type as XML reader, which is what they then define also as the like final payload. So it's going to eventually create that XML type, and it's going to have this string as an argument to the function. So basically, in the end, this is what's going to happen. So it's going to call that convert to, and they are able to control the target type, and they are able to control the argument sent to the function. And that leads to code execution. And this is like really, really cool. But the thing is, this only works in PowerShell, in Exchange PowerShell. Because this is a vulnerability in Microsoft Exchange serialization type converter, right? So this doesn't really work for what we're after, right? Because we want to exploit PowerShell in general. We don't only want to own the Exchange servers. So this is a really, really cool exploit. I recommend that you read the write-up from Zero Day Initiative on it. But we're going to take some learnings from here and see that user-defined types are dangerous. And we're going to see what user-defined types are available by default in PowerShell. So I looked at my newly installed Windows 10, and it seems that user-defined is a kind of a bad name for this, because there's quite a few of them that ships with PowerShell by default. And if you look at the server, then you see like maybe you have a SQL server, then that also comes with PowerShell modules, which also defines user-defined types. So eventually you're going to have quite a few of these types on your system. And on top of that, there's also a hard-coded type converter, which is like the default type converter. And I think this is made to like support PowerShell remoting and some things like that. So there's actually additional types that are just built in to be rehydrated as well. So if we look at one of these like default types, we have PS breakpoint. So in this case, we have a command breakpoint, and we serialize it. And we see that within the serialized breakpoint, we have an attribute called action, which is a script block. And that is naturally deserialized to a string, right? Because it's dangerous otherwise, right? No? OK. So if it's in a breakpoint, then it's actually deserialized as a proper breakpoint. So that's interesting. So how did that happen? It seems that this custom function for the serialized breakpoint actually calls explicitly rehydrate script block. And that runs a script block create. So you're going to get the script block back. And naturally, we ask ourselves, what did the Microsoft developers mean when they said that there's too many places where there's automatic code execution? Well, it seems that PowerShell has this concept of delay bind parameters. And if you, for example, do what we're doing here, so we have like a pipeline stream, and we do for each object, and then we specify our deserialize.action there. That's going to execute code. That's going to execute the script block. But thing is, these are everywhere. So if we do a select object, that's going to execute. If we rename a file with that name, that's going to execute. If we pretty much wherever we put it in the pipeline, it's going to execute. So it's a pretty interesting gadget. It's also kind of worthless, right? Because how often does someone use .action and put it as a parameter? So it's not that useful, but at least this is our first step into this, right? We can sort of show that you can't just deserialize CLIXML and trust the data, because it could end up with code execution if you use the code in a completely legitimate, but you're just unlucky way. So let's continue and look into the other gadgets or classes that we have available. So one interesting type is the SIM instances, because those are also rehydrated. And let's look at Win32 ping status. That defines something called a type PS1 XML. And that is a way to dynamically enrich your types in PowerShell. So often PowerShell modules comes with a types PS1. And what this one says is that take the object and then enrich it with this IPv4 address property. And what it's doing is that it's taking this address and then it uses the getHostEntry call to enrich that and print it in a fancy way. And then there's this format file, which is kind of the same as types, but it's for the outputting of the object. And it says that we're going to print IPv4 address by default. So I don't know if you noticed, but in PowerShell, when you, for example, querying a reg key, then it's kind of beautifully printed, and it's not default, right? That's because it has a types file to say what's going to be printed and not. But what happened then, because that getHost function, that is going to make a DNS request to whatever domain name we provide. So this could be a gadget to make an arbitrary DNS request, right? So if we change the address field and then we import this, we observe that PowerShell is making a DNS request. So that's not really that big security impact, right? But it could be useful if we're looking for vulnerabilities. We could find that something has deserialized my payload. So it could be useful in that sense, like Java has similar ones where you can do a DNS request and so on. But I think it's more important because we're kind of learning now, right, how do we make these kind of gadgets possible? So what we need is that the victim, of course, needs to deserialize the CLIXML, and then we need to have a class that's going to rehydrate, and we need some kind of useful property, and it needs to be printed by default. And it actually seems like there isn't that much that rehydrates, but then again, quite a lot rehydrates, right? We have all the known primitive types. We have all those types in the default deserializing type converter. And we have SIM instances, and then we have whatever user-defined types that this specific system has. So let's continue our path into looking into what else do we have. We have the SMB share PowerShell module. It defines this preset ACL path, and it does a get path to whatever value that we as threat actors can control, right? Because in a deserialization context, we control all these attributes. So what if we set it to something like this? Then the get ACL is going to authenticate to evil server, and we can capture the net and TLM v2 hash, right? So we try importing that and see if we can steal the hashes of whoever deserializes our payload, but it doesn't work. So why doesn't it work? Well, there's a difference in PowerShell between available types and loaded types. And it seems that when you use a PowerShell module cmdlet, then it's going to implicitly load it. So it's going to feel like they are always available, but technically they're not always available until you've used them. Or you explicitly import them with import module. So that sort of limits, but I mean, as soon as we do get SMB share and then we do it, then it works. But there's also another problem, which is that this is a kind of a weird name of a variable. So this is not printed by default. It's not in the format file. So to actually make this work, we need to do these three things. We need to first import that actual module, then, or like the victim needs to do this. Otherwise, they're not vulnerable to this specific gadget, right? So they need to somehow import the module and make it available. Then they need to deserialize the untrusted data. And then they just need to like access all the objects. Because as soon as you access the property, then this is going to trigger. So when you do that, you see on your backend side that, yeah, now we captured the hash of this user. And by the way, that happens quite a lot, right? So if you do like a select star, if you convert it to JSON, there's a lot of situations where you access all these properties. But still, like, we need a better gadget than that, right? So let's look into the registry key class. In this case, it has a getItem property, and it takes the PS path as the argument to that cmdlet. We can control that value, of course, because we are deserializing this object. We can construct it in any way we want. And the funny thing here is that this is loaded and made available by default. It is printed by default. So all the victim has to do is import our CLIXML, and boom, we have their hash. So that's kind of nice. If we look beyond what I have on my system right now, we need to start thinking about PowerShell Gallery and the entire like ecosystem of modules in PowerShell. And we have one example, which is PS Framework. It has like 6 million downloads. It's developed by someone working at Microsoft. It is used by 4 official Microsoft modules. It is also used by some incident response tools and other quite well-used tools. So you can imagine if you start enumerating all the like dependencies and dependencies and dependencies of this, there's quite a few people that have this stuff on their machine, right? Guess what that modules type like thingy look like? It's a wrapper just like Exchange on the binary formatter. So in other words, on all those machines, we can execute code when they deserialize CLIXML. And I illustrate that this way. So of course, PS Framework is definitely the only gadget out of these like 13,000 modules on PowerShell Gallery, right? That's vulnerable to this. Especially since this is new research, right? There isn't a single page on Microsoft that recommends how you should develop your PowerShell modules to not introduce gadgets. Because, yeah, this is fairly new. So no one really knows that this is a problem. So pretty much, I mean, yeah, there's a lot of vulnerable modules, obviously. But none of them have a security file, and I have another job, and it's really hard to, spending time trying to reach people. So we'll see. If you want to find CVEs, there's quite a lot of them in the PowerShell Gallery if you want to find gadgets. OK, so let's summarize what we learned so far. So we only looked at like what happens at the actual serialization. We're soon going to look at when is this actually a real problem. But if we just look at it very closely in like the actual serialization, then we see that if someone has a fully patched vanilla PowerShell without any weird configuration or modules installed, we can make an arbitrary DNS lookup, we can steal hashes, and if they use the property action, we can execute code. That's by default on a fully patched Windows machine. If they have an unpatched Windows machine, they have a bunch of other problems, but these are fairly old, so I guess everyone keeps their systems up to date, right? By a non-default, we also have code execution. So we have code execution, like I talked about, in these like official Microsoft modules and everything like that. But that requires you to have them available in your session. So it's a bit different. So I think it's, I don't know, do you agree that it's not a good idea to deserialize untrusted CLI XML? Is that a yes? OK. Good. So let's look at PowerShell remoting. It is this thing in Windows, right? It's the recommended way to manage your IT environment. It has like that you can just invoke a command on a system. You can enter a session and get like a SSH kind of feeling. If you're using Windows Admin Center, this is what's used under the hood. And yeah, a lot of like admin tools use this. This is like the way to manage your enterprise environment. The protocol looks something like this. So it's a web protocol, and it uses SOAP, and it has like this WinRM extension, and then it's built with PowerShell remoting on top of that. And it has this like really boring documentation, but I figure it's more fun if we explain this using burp, because it's web, and everyone knows web, right? So this is me with burp doing PowerShell remoting. So we see that in the actual data that's encoded with base64 and so on, it's actually CLIXML that's sent. That's how PowerShell remoting is sharing objects between machines. So if we run like a who am I, then it sends the who am I, and then after that you're gonna like request the response, and it sends these streams of responses, and within those streams you have CLI XML. So that's how you get that kind of awesome feeling when you use PowerShell remoting, right? Because like you have your PowerShell object, you do invoke and blah blah blah, and it just kind of works, and objects are rehydrated back and forth, and it's really nice. But didn't we just agree that you should not deserialize untrusted data? So what happens if the server you're talking to is compromised? Well, then they can send something else back. And your PowerShell prompt is just blindly trusting whatever the PowerShell session is returning to it. So that's not, that's not good. So I wanted to implement this POC, and there's quite a few challenges because PowerShell remoting is a pretty good solution. It has quite a lot of security features. It has like this encrypted channel using HTTPS, so we can't man in the middle it. Like even if we manage to do that with certificates and stuff, then the actual data is also encrypted within the SSL channel. And it uses Kerberos, it has mutual authentication, and by the default, it only connects to the trusted systems. So basically, you can only do this to a domain-joined system. And if we solve all of that, then it's still like this undocumented compression, which is just like, a pain to reverse and try to figure out how that works. So I really didn't want to solve all of this, so I started looking into how else can we hijack this. And I looked into the architecture of the, you have WinRM and you have PowerShell remoting on top and so on. The way that actually implemented is that PowerShell is a plugin to WinRM. So you can see this if you just list that vsman PowerShell provider, right? You see the file name is that PowerShell plugin to the WinRM service. So remember that PowerShell is open source, right? Can't we just roll our own PowerShell? So I looked at the code, and I found that this fragmenter CS serialized to bytes is where we need to do the magic. So if we just do this as a proof of concept, I have this return value, which is, if I run a who am I, that's what I'm going to get. So in the other demos, we're going to implement some logic here. But we're going to reply this string instead of our username just to see that this works. We build it, and we also build that PowerShell plugin file. And then we hook the default plugin for PowerShell. And we try it out. So we run the invoke command towards this server, and we see that we get the string back. So it actually worked. And not only did it get the string back, it also stripped away those S tags around the string, right? So we know that this actually deserialized our malicious payload. So the actual implementation of this is going to look something like this. So you have the unsuspecting user connecting to a machine they don't know is compromised. That machine returns a bad response, and something bad happens on their client. And let's take a look at a demo of this. So we can just kill that Hyper-V. And we're going to start looking at this Web 19. So here I have a Windows server, which is compromised. And it says that the vsman localhost Microsoft plugin is pointing to my bad PowerShell. And that's all I need to do on this compromised machine. So on the other side of things, we have a domain admin here, Bob admin, who wants to run commands and do some kind of work on that machine. And the third machine that we have is this Meterpreter, or not Meterpreter, but it's a Metasploit listener to capture these challenges, right? So if everything works, we are going to be able to exploit this and get the password hash of the domain admin. And the actual exploit looks like this. We're not going to detail it in too much detail, but point is, this is where it's going to look up. So it's going to make this SMB request, which is also going to authenticate to the this Metasploit thingy here. All right, so just before I start, just to show you I'm not cheating or anything, I don't have any modules loaded here. This is just the default that you have. And the only thing I'm doing is I'm running the command hostname. I can run any command, it doesn't really matter. And as I do that, we'll see if my demo actually works. And we got the hash. So this hash here is the netNTLM v2 hash. It's part of that, creating the SMB connection. It's a challenge response thingy. But it actually contains the password, right, of this user. So we have this yon file where we saved that, and we can actually crack and get the password of the domain admin. So if the password was much stronger, it would be much harder to crack that. But of course, you can do it offline, right? Because you have captured the challenge, and you can use all your computing power to get that back. And the final thing, we can check who's domain admin using Bob admin and the password we just cracked. And we run the net group domain admins /domain command. And hopefully, we're going to get a list of domain admins from the domain controller. Or otherwise, you just have to trust me. This is a domain admin, and this is kind of outside of the point, right? So that's not a good situation, right? Because PowerShell remoting is the recommended way to do this kind of thing. Like when we at TrueSec do investigations, we use PowerShell remoting to collect data from compromised system, because you don't want to, for example, RDP to one of those systems, because it's super bad because you expose the credentials. But it turns out that PowerShell remoting, you kind of have similar problems, right? So we're gonna, before you panic, we're gonna talk about what we can do about this. I'm not just gonna leave you with everything is burning, but it's not a good situation. And PowerShell Direct is the other attack vector of this. Same fundamental technique that they use in PowerShell remoting, so they're very similar. The big difference is that they're using VM bus for transport instead of TCP/IP. So it looks something like this, and it's this it's not based on network, right? So your VMs can be completely isolated. It's just going to hook into the virtual machine and talk to it directly. But aside from that, it's exactly the same thing. So it's going to take your CLI XML, it's going to return CLI XML, and that client is happily going to serialize whatever we give it. So problem here is I'm not that good with reversing and when it comes to hypervisors and try to figure out how do I intercept something on a VM bus. That seems awfully hard. So I looked into how is PowerShell started, because that should be a user land process. That seems much easier. And it starts with this SO flag. So it's like a socket mode kind of thing. And when you look at the events prior to this, you realize that Microsoft is, or Windows is, looking for PowerShell with the search path. So what if we put our own PowerShell first in that search path? Well, then it's going to find our PowerShell instead of the real PowerShell, and we don't have to care about some hypervisor magic. We just need to hijack PowerShell, and then we're good. So here we have like a log. I mean, we can start just logging whatever is being done, because this is sort of a blind situation, right? But we can just monitor and see someone using PowerShell Direct in this virtual machine, and just start monitoring and seeing what type of things are they doing. But then, of course, we can also return something bad. And the demo I showed in the beginning looks something like this. So it hijacks PowerShell XC, it runs that patch serialize the byte function, and it sends the exploit, which starts a PowerShell like C2 on the hypervisor host. And since we don't have any network and we cannot assume anything, we're actually just using the VM bus channel as the C2 channel back again to get that reverse shell. And it sounds way more complex than it is. It's pretty much just a copy item. The tricky part is kind of writing that patch to serialized bytes to allow enough of the legitimate protocol to not return our payload all the time. So you kind of need to have a allow list there to make that work. But this is what we saw in the first demo. So on the hypervisor host for this to work, they had a official Microsoft module installed. It's not default. And it does require user interaction, right? Because the hypervisor admin needs to run invoke command to make this trigger. But keep in mind that there's also like backup solutions that use this. So it doesn't necessarily have to be an admin that's in there doing that. It can happen recurringly in some cases with the software installed. So I reported this to Microsoft back in March this year. And a few days later, they confirmed this as, they confirmed the behavior. And then a few days later, they closed the case without any comment. I asked what they did about it, and they didn't answer. And then I talked to my friends who work at MS and also some MVP friends that I have. And we escalated it pretty much every way I can think of, and we got them to open the case again, which was awesome. And they said that, thank you for submitting this. This issue has been fixed. And then they acknowledge it and everything and so on. But I asked, like, do you want my help? I mean, we can sit down and see that this patch actually works. It seems like this would be kind of trivial, not that easy to fix, because this is a very fundamental problem in Microsoft, right? But I didn't get any answer to any of this. This was the last message I got from them. So I updated my machines. Everything still worked, just as I have presented it here today. So I kind of initiated a plan B, and I started reaching out to that employee at PS Framework to at least fix that. He did a great job and started fixing it. Unfortunately, he has stopped replying since like Tuesday, but I hope that he will publish a patch pretty short. But it's kind of weird that, that PS Framework, I just assumed that they would fix that because the PowerShell modules that are Microsoft official is covered by MSRC. And they have code execution vulnerabilities. But yeah, we are now 180 days into that report, so I think it's appropriate that we talk about it so everyone can start doing something about it, because there's actually things we can do to make sure that this doesn't happen. Because maybe I'm not the only one who knows this, right? Maybe this is exploited already. So if you're an IT admin, what should you do? You should start with just knowing that this is a problem. So start trying to figure out what PowerShell modules do you have on your system. Are you using PowerShell remoting from your all-in-one admin PC, where you're also developing PowerShell modules and you have like 1,000 modules installed? Then you're probably really, really vulnerable to this. So you need to have a privileged access workstation that is only meant for administrating. You should have that anyways. But this just adds one additional reason for that. And I mean, as long as Microsoft does not fix the actual vulnerability, which is the deserialization of untrusted data, all of us need to figure out what gadgets we have on our systems and try to diffuse those. So if you're a vulnerability researcher or a security professional, then please help me try to find all those and report all of them so we can fix the gadgets. It would be better to fix the actual root problem, but here we are. And as an IT admin, you need to update your PowerShell modules, because hopefully these will start being fixed with this perspective in mind. So that's the high level of what you should do. And if you're a PowerShell module developer, and if you're just an admin using PowerShell, then maybe it's a good idea to just avoid CLI XML. You can use JSON, for example. It's also portable between systems. I don't see any good reasons to actually use CLI XML unless you need the rehydration. Then that's a different question. If you didn't even know that it rehydrates stuff, then you could probably just use JSON, and you're not having these problems. If you develop a PowerShell module, know that if you by accident introduce a module, a gadget, then anyone who installs your module will have that additional attack surface when they use PowerShell remoting. It's kind of crazy, right? If we install a module which by itself doesn't have a vulnerability, then all of a sudden we have code execution when we use PowerShell remoting. And that's how fragile this system is, because it uses these types, right? So we need to, if we're developing PowerShell modules, we need to be really careful with our types and formatters, and think in a way that the threat actor can control all these attributes. We need to make sure that they are not abusable in this way. And I know this has been a lot of information, and I'm sure that, or I hope at least, that some of you is going to take a look at the recommendation and do something about this, so this doesn't have to be a problem. And tonight, I'm publishing this research article. You have the link here if you want to read all the details and so on. And with that, thank you for listening.
Thank you very much. We're just going to do a quick shift and go directly, I think, into the next speaker on stage. And we're going to do some Q&A with you down in the Q&A studio as well. So, yes.